Let's consider the properties of fluid. Now, I told you that we have majorly four properties of fluid mechanics. Now, the first one is what we call the mass density. The mass density. So you can call it mass density, or you can call it what? Specific mass. So if you're not hearing mass density, you will be hearing what? Specific mass. You might be asked to calculate for your specific mass. Now, your specific mass is denoted with small letter m. Small letter m. We use this to represent our mass density or our specific mass. Now, what's your mass density? Mass density is basically the product of what? Mass per unit volume. The product of what? Mass per unit volume. So when we are considering mass density, which is small m, your small m is basically mass divided by what? Volume. That is the formula you use to calculate for your mass density. Now, what do you think the unit of mass density will be? The unit of mass density will simply be what? Kilogram, because your mass is measured in kilogram and your volume is measured in what? Meter cube, right? So the unit for mass density will simply be what? Kilogram per what? Meter cube. Or better still, we can have kilogram meter raised to the power of what? Minus what? 3. Am I communicating? Now remember, what we have here, which is what? Mass over volume, is the same thing as density. From our elementary physics, we know that density, when we are talking about density, density is basically the product of what? Mass over volume. So density here is the product of what? Mass over what? Volume, right? So if we have density to be mass over volume, we can say that if we want to represent mass density or specific mass, we can represent specific mass with small letter m, or better still, we can use the symbol for density to represent what? Specific mass. I'm just trying to explain this. So in essence, where you now see this density symbol as a representation for specific mass, you will not get confused. Am I communicating? Because if you get the unit for density, you can simply arrive at density is mass over volume, which is the same thing as what? Kilogram per what? Meter cube. And it's the same unit with what? The unit of what? Mass density, right? So if you want to represent, if it's an exam situation or is a kind of a test case where you're now seeing rule to represent your specific mass, you should not what? Get confused. Am I communicating? Now, after we've considered mass density as a property of what? Fluid mechanics, let's consider the next property of fluid mechanics. Now, what do you think the next property of fluid mechanics will be? The next property of fluid mechanics is what we call the specific volume. Now, the second one is what we call what? Specific volume. Specific volume. Now, somebody will ask me, what's specific volume? Specific volume is the product of what? Volume per unit mass, and it is denoted with small letter v. And when we are now considering specific volume, which is small v, is equal to what? Volume divided by what? Mass. Am I communicating? So what do you think the unit for specific volume will be? For you, the unit for specific volume will simply be what? Millimeter what? Meter cube divided by what? Kilogram. So in essence, you're not having meter cube divided by what? Kilogram. So basically, this is the unit for what? This is the unit for specific volume. Now, looking at what we have here, remember, we said density is a product of what? Mass over what? Volume. But in essence, we are saying volume over mass here. So can we extract volume over mass? Can we extract what we have here with what we have here? So if we do that, you can simply say that what we have here, specific volume, can also be represented as what? 1 over what? Density. Now let's see if 1 over density will simply give us volume over mass. Now remember, what is density here? So density here will be 1 over mass over volume, right? Now remember, elementary mass, what we have here can be written as 1 divided by 1, right? Multiplied by, if you are multiplying, your volume is coming up, your mass is coming down. So we simply have volume here divided by mass, right? So if you do that, this will simply give you what? Volume over mass. So we can see that we are still having volume over mass here. Here we are still having what? Volume over mass. So we can represent specific volume to be small v, or 1 over what? Density. Am I communicating? So in essence, if you are now seeing your specific volume in your question to be 1 over density, you should know that it is the same thing as your what? Small v. Am I communicating? Now let's talk about the third property of fluid mechanics. The third form of fluid mechanics is what we call our specific weight. Specific weight. If you don't call it specific weight, we can also represent it to be what? Specific, or weight density. We can call it to be weight density. Density. Now, looking at everything we've been calculating for, you can see that almost everything is having density. So meaning everything will be related to what? Density. Am I communicating? Now, for your specific weight is always denoted with small letter w. Now, your small letter w is simply what? The ratio of what? Weight per unit volume. The ratio of weight per unit volume. So when we are talking about specific weight or weight density is simply what? Weight over what? Volume. This is the formula you use to calculate for your weight density or your specific weight. Now remember, if you want to get the unit for your weight density, the first thing that should come to your mind is, what is weight? What is the unit for weight? Now the unit for weight is what? Weight is basically measured in what? Newton, right? And what's volume? Volume is what? Meter cube. So the unit for weight density, after all your calculation, you simply have the unit to be Newton per what? Meter cube. Am I communicating? Now remember, what we have here is written as W is equal to capital W, which is weight, right? Divided by volume. Am I communicating? I made mention that all the properties that we have here must have something to do with density. Am I communicating? So now looking at what we have here, what is the relationship between your specific weight with density? Now, what is weight? When we want to calculate for weight from our elementary physics, we know that weight is what? Mass times what? Acceleration due to gravity. So we have mg, which is mass times acceleration due to gravity, divided by what? Volume, right? So what we have here can be written as m dot g, that's mass multiplied by acceleration due to gravity, divided by what? Volume, right? Now looking at what we have here, we have mass over what? Volume. And what's mass over volume? We know mass over volume to be what? Density. So in essence, your specific weight, you can also use the formula density multiplied by what? Gravity. So this is another formula for you to use to calculate for your specific weight or weight density. While I'm breaking down this formula, and I'm trying to show you a new formula for you to use, is in a case where you are now giving density and you're now giving what? Acceleration due to gravity, or we know acceleration due to gravity to be what? 9.81, right? So if we know what acceleration due to gravity to be 9.81, and we have density, we can still use this formula to calculate for our specific what? Weight. Am I communicating? Now let's take down the last one, which is what? The specific gravity. So it is fourth property of fluid mechanics, and the fourth property of fluid mechanics is what we call the specific gravity. Specific what? Gravity. And the specific gravity is represented with what? S dot G. S dot G. Now, when we are now considering specific gravity, we are going to consider specific gravity of two things. We are going to consider the specific gravity of liquid, and we also consider the specific gravity of what? Gases. The specific gravity of liquid, and you also consider the specific gravity of what? Gases. Now, when we're now considering the specific gravity of liquid, we are considering specific gravity of liquid in two forms. Now, the first one is S dot G of liquid. It's simply what? We are going to consider the specific mass of that liquid divided by the specific mass of water. So in essence, for you to calculate the specific gravity of a particular liquid that will be given to you, the first thing you do is calculate the mass of that liquid. Get the mass of that particular liquid that is given to you. The mass of the water will be given to you as a constant value in your question. Am I communicating? Now, this is the first form of how to calculate for the specific gravity of a liquid. What if in a case where you are now given the weight of the liquid? How do you calculate the specific gravity of a particular liquid? Now, if you're not given the weight of a liquid and you're not asked to calculate for the specific gravity of that particular liquid, what you now do is you apply the formula specific weight, specific weight of the liquid divided by the specific weight of water. This is the formula you use to calculate for specific specific gravity of a particular liquid. So we have specific weight of what? So what happens is you are going to be given the specific weight. You are going to be given the specific weight of water. So what you do is you calculate for the weight of the liquid or what the mass of what that particular liquid. What if in a case where we are not asked to get the specific gravity of a particular gas? So let's say you are given a particular gas and you're not asked to calculate for the specific gravity of that gas. What formula are you going to use? Now you basically apply this formula. Specific gravity of a gas will simply be what? You simply calculate for the specific mass. You simply get the specific mass of that gas divided by the specific what? The specific mass of air. So what happens is you are going to be given the specific mass of air in your question, and what you do is you get the what? The specific mass of that particular gas that you were given. So what you do is you input those values into this given formula and you get the specific gravity of that particular gas. Am I communicating? So what you'll be given in your question is you'll be given the mass of water, you'll be given weight of water, and you'll also be given what? The specific mass of air. Am I communicating? Now let's take down some examples for more clarification.